page 16. You can designate two different equations, two linear equations, as a system of equations with a left bracket like this. And now what you're doing, the objective of having this, is to find a common solution that satisfies both of these equations. That means you want to find the ordered pair, which is the x and the y coordinate, that both makes both of these equations true. Now if these in fact do have a common solution, then we can call them simultaneous equations. A simultaneous equation is two linear equations that have one common solution, at least one common solution. So the way you figure that out is we're going to have to graph each of these on our coordinate plane down here, and then we're going to find the intersection point. The intersection point between these two lines is going to be the common solution that satisfies both equations. So let's start out with the first one on top. Let's just throw out a few different numbers and then we'll graph those points so we know where it is. Okay, so when x equals 1, we're going to put 1 into here, so that's just going to resolve to 3, because 3 times 1 equals 3. So why don't we write that down here? It's going to be 3 plus 2y, we don't know what y is yet, we're solving for that, equals 6. Let's go ahead and isolate this, move the 3 over, subtract 3 from both sides, so this just becomes 2y equals 3, and then divide each side by 2, and y is 3 over 2. So we know that one. So let's look at another point. Let's say when this is 2. We're sort of running out of room, so let's put it over on the other side. So this is going to be 3 times 2 plus 2y equals 6. This resolves to 6 plus 2y equals 6. Subtract 6 from both sides. You're left with 2y equals 0. Now if you divide the 2 to each side, it's still going to stay 0, because 0 divided by 2 is 0. You can put 2 into 0 times. That's another way to look at it. So y equals 0. So let's bring it over here. So when x is 2, we know y is 0. Let's go ahead and write one more down. It's good to do 3. Let's just do 0. This might be an easy one. So 3 times 0, right here, 3 times 0 plus 2y equals 6. Let me show you there. 3 times 0 resolves to 0 plus 2y equals 6. Go ahead and divide each side by 2. Y equals 3. So now we have our 3 points. Let's go ahead and graph these and see what the line looks like. So when we go 1 over for the first one, 1 over, and then pretty much 1.5 up. That's what 3 over 2 is. Right here. So the next one is 2 over and then 0 up. So that's right here. The last one is 0 over and 3 up. So we're not going anywhere here, but we're going up 1, 3. Alright, so now you can sort of see what this line is going to look like. It's just going to be a line like this. We can take our straight edge. Go ahead and mark this down. Alright, so it's a good idea when you do that to just write the equation right beside it so we know which one that is. We don't confuse it with another one. So remember, from up here, see right up here, 3x plus 2y, 3x plus 2y equals 6. So that's this equation, this linear equation right here. So let's go ahead and solve the next one. We're going to have to put it right down in this quadrant. So I'm going to rewrite it down here so we can see it. 5x minus y equals 10. Do the same thing we did before. Just look at a few different points. So let's try 1 first. When x is 1, it's going to be 5, 1 minus y equals 10. Then this just resolves to 5. Because 5 times 1 is 5. There we go. We're going to have to do two things. First, we're going to have to move this over to change its sign. We want a positive version, the y. And we're going to have to subtract the 10 back over to this side. So let's first start out with adding y to both sides so we get the right sign on it. I want a positive sign. So 5 equals 10 plus y minus 10. And you're left with negative 5 equals y. So we figured out that one. Let's go ahead and go with 2. So 5, 2 minus y equals 10. This resolves 5 times 2 is going to be 10, so this resolves to 10. 10 minus y equals 10, and we're going to do much like the other equation. We're going to need the positive sign for y, so we're going to have to plus it over here, and then we're going to have to get rid of this and subtract it to over here. So let's do it all in the single step. So we have to write it twice. So this is going to plus y to each side, and we're in addition to that, we're going to have to subtract 10 from both sides to get this 10 over that side. So as you see, this negative 10 cancels out both of these 10s, so you just have 0 on each side, and we're left with 0 equals y. So write it up here, and let's go ahead and do our last one. Our last one will be 3. So I'm going to write it over here. So 5x minus y equals 10. Remember that. 5 times 3, plugging in 3 for x, minus y equals 10. 3 times 5 becomes 15, minus y equals 10. Then plus y to each side. 15 equals 10 plus y. Subtract 10 from each side, and you're left with 5 equals y. So we finished the last one, did all the hard work. Let's go ahead and graph it. That's the fun, easy part. So let's go 1 over and 5 down, it says. So 1 over, 5 down. 1, 2, 3, 4, 5. There's 1 point. The next point, 2 over and 0 up or down. So 1, 2, it's right here. It's actually, this is the intersection point, it looks like. The next one, 3 over and then 5 up. 1, 2, 3. 1, 2, 3, 4, 5. Right here. Let's go ahead and connect all those dots. All right, so we have two lines. Now let's remember so we don't confuse them. Let's label this one. Usually want to make it going along with the line. This was 5x minus y equals 10. There. So now you have two of them, and you found the intersection point. This intersection point right here is the common solution. So you know now that the ordered pair to solve both equations, which are simultaneous equations because they have a common solution, is going to be 2 over and 0 up or down. And the way we write that in an ordered pair is, remember, it's within a parentheses. And you first put the x-coordinate, then a comma, and we're going to do the y-coordinate, which is 0. And then you close the parentheses. And there's your answer. That right there is the ordered pair that satisfies both equations.